Hi everybody and welcome back to another video. In this video I decided to look a little further into Duckdb, which is one of my favorite things to do these days. I like that quite a bit because it's so easy to work with, and it has some nice features too that some of the good community out there has provided for us. In this video I want to look at using VSCode and the Python wrapper around it so I can work with Duckdb in a Jupyter Notebook inside VSCode. Without further ado, let's get started. Okay, so just some housekeeping. If you need to get a hold of Duckdb by itself, or you just want to get to the documentation, just go to duckdb.org docs. And then you'll find the documentation here, installation, how-to guides, stuff like that. And you can also go to the GitHub repository right here. Make sure you take a look at this documentation because there's a lot of good sample code and examples and so forth. Yeah, go there first and then read up on Duckdb and what you can do with it. Now, the second thing is that I want to open up my VS Code. So here it is. And I have this dark mode on. I hope that's okay. The first thing I want to do then is I want to go and select a folder that I'm going to be working with. So I'm going to open folder, and I have some folders set up here under my folder structure here. So the one I'm just going to use for now is this New York City taxi trips because it illustrates some, and I don't have to do much cleaning or anything. I tried some of these other data sets, but there's so much stuff and I don't feel like sitting cleaning those files all the time. So here I'm setting the folder, and the only thing I got in here is a notebook, as you can see. So I set up some download links for you here so you can download it directly from the Duckdb website. And one of the nice things about the website here is that they have a bunch of data. I'm not going to download anything yet. I'm just going to leave it because I want to illustrate some stuff. When you start working with this, you need to set up your terminal. So you choose your Python and you choose which one you want to use. Now, a shortcut for that would be Control-Shift-P, I think it is. And then you can go to Python, select interpreter, and then you choose for whatever list you have available. The one I'm using is this Tor environment because I got a lot of libraries installed there. So I'm just going to use that one. Okay, so let me choose that. You can see it's over here, it's set up. This is an IPy notebook. So just in case you wonder, you can go in and set up this markup. You can use HTML or you can use the markdown language. Here I got 3 pounds. It's probably equivalent to an H3 or something like that. So that's one type of cell. And then here is another markup cell that I did where I use italics. And I use this little tilde sign here in front and after, so it looks like more like code. I have some information about Duckdb, about Magic Duckdb, about polars, about NB format, and Plotty Express. Some of these libraries you might want to check out if you're going to be working in Python. Now, I'm not going to use all of those. Particularly, I'm going to use the Magic Duckdb. And of course, we're going to use pandas and so forth. Okay, I want to import some libraries. So you see I'm importing Duckdb. And before I do that, let me just show you what I'm doing here. I have an Anaconda prompt set up here so you can see it. And all I really need to do is activate it. So I can say, I use miniconda 3, so I say conda, activate the Tor environment. And now it's activated. So if I do a conda list here, you can see what I have installed. And I want to point out that I have installed, if you look here, you see I got this Magic Duckdb set up. Of course, I have pandas and polars and stuff installed here, but I'm not going to go through that today. So anyways, you want to make sure you have those packages installed. Let me run this command. So I'm going to load those libraries, and there we go. Now, if you work with Python and if you work with Duckdb, you probably have seen this Duckdb prefix .SQL when you run SQL queries, or duckdb.execute, for example. Now, what's beautiful about this is that you can use this Magic Duckdb, and therefore you can run SQL statements directly without marking them up with a string format and stuff inside this duckdb.sql. In order to do that, you can have this percentage $DQL prefix if it's a single line and double percentage if it's a multi-line. So scroll down to README and you can see some information they have, and they show you some examples here how to use this, like quick starts and how to use it and different flags and so forth. So make sure you check that out because it gives you a lot of information. Another thing is you can go in to the notebooks here, and when you do that, you're going to get a list of different notebooks, and they show you some different examples. So for example, if you go to examples here, which is a Jupyter Notebook, they show you some code that you can use. So I've been hacking into this and using this and come up with some ideas for how I can use it inside my own Jupyter Notebook here. So with that said, you can set up the formatting, and there is some different formats, and I'll show you that. But you can do this percentage DQL -T and DF. What that stands for is that you want to output this as a data frame, a pandas data frame. Now, one of the reasons you may or may not want to do that is because when you're working with DuckDB, if it converts it into a data frame, everything becomes in memory. So if you have a lot of data, that's not necessarily good. So you can still use some other types, as you can see above here. With this -T, you can choose from a data frame. You can use arrow format, which is very efficient if you have a lot of data. Now this PL, I'm not sure what that stands for. I didn't really use that one. And then I use show quite a bit too. So you can read up on what these do inside that documentation for the magic DuckDB. Okay, so let's take it for a spin. Now, there is an extension in DuckDB called HTTPFS for file system. So it's basically you can look at files over the internet connection by using this extension. And in order to use it, you simply install it and load it. So you can say install HTTPFS and then load it afterwards. So it's pretty easy to do. So I'm loading it, and then I basically use some formatting here just so I can get some comma. And yeah, you can use this format function, parenthesis, and then a squiggly mark, colon, comma, squiggly mark inside a text representation. Then you do a comma, and then you do whatever you want to format inside in this case, a count, and then the end of the parenthesis. And I give it a name, and then I say from, and then I'm querying directly this Parquet file out there on the internet. So let's run this and see what happens. Okay, so notice it came back and it says there's 7,433 rows, and this was over the internet. Now, you might wonder, how could it be so fast? Well, it's a little cheating because this is a Parquet file. And one of the strengths of a Parquet file is that it will give you metadata. So when it queries, it can simply count up the row groups and get the counts from there. So it's a pretty fast when it comes to this kind of queries. That was the count, and notice the format of the query. So here I'm going to query from that file directly out on the internet. I'm going to limit it to 5 rows, and I'm going to time it, and then I'm using my double percentage DQL magic function, and then I'm setting T to return a data frame. So that's what I'm trying to do with this one. So Control Enter to run this cell, and it's going out there, and it took a couple of seconds here to get out there and get it. Now, one thing I noticed, sometimes this is acting up. It doesn't come back and give me the right format. So if I do show here, let me see what it does then, if that's better. So I'm going to use show instead. So I get the DuckDB format coming back. As you can see, it's like more like a Spark output. So now I got it because I used this show method. So sometimes the data frames doesn't load properly in here. And sometimes I have to move the from clause up a little bit because I think it might provide some new line returns or something. So anyways, I just queried from this internet file, the Parquet file, actual data coming back from those 7 million rows, as you can see. One thing I can also do is I can inspect the Parquet file by running some averages and so forth over it. So here I'm doing a count, but it should run pretty quick because it's part of the metadata. So it should run fairly quick. So as you can see, it gives you this progress bar, and it's finishing here. And as you can see down here now, notice one thing here, max fair amount was, oh boy, how much is that? $395,000. That's I don't know where this guy was driving, but maybe there might be an error or something. One thing I can do also here in this notebook is to figure out where is my current directory. Okay, so it's pointing right here to this New York taxi trip folder. So that's correct. That's what I kind of want to make sure it's there. All right, now one of the reasons I want to do that is because I want to save a file, and I want to save it to the right folder. So here I'm going to create a local copy of that Parquet file, but I'm going to get it over the internet directly and download it and stick it into this folder of mine and give it this name. So let's see how long that will take. There's a lot of records in this file, as you've probably seen. So I'm just going to keep running this and let it run while I'm talking about something here. Did it finish? Wow, that was fast. Okay. So let's verify this. This was almost too fast. Okay, so let me run a query against this and see how many records are in my local copy that you can see over here. This file now is my local copy. You can't really read it because it's a Parquet file, but let me try to see if all the rows are there or not. That was awfully quick. It looks like it is. I mean, here is 7. And I'm querying the local copy here, as you can see. So that was pretty weird, really fast. Okay, so let's take a look at some of the things we can do here with the syntax of the Duckdb. Notice I can use this columns function, which is kind of nice. It expects a lambda function. So you're saying for C, in C like T %. So in other words, what I'm saying is create a variable C and look for any column that starts with a T inside this local copy here. And let's just limit it to 5 records so that it doesn't become too much. Okay, so I'm running it. And as you can see, it came back with all the columns that start with a T. So if I want just the ones who start with a TO, then I'll simply type in the O here and run it. And if you look now, I'm only getting back those columns that are TO. So it has small little features like that makes it kind of fun to work with. Okay, here's another query. I'm going to describe that Parquet file so I can see what it looks like. So let me run that. And as you can see here now, it comes back with a column name, the column type, whether it accepts nulls or not. Yeah, so you can see what it translated here, timestamps, etc. So that's the describe function. Let's look at the metadata of the Parquet file. The thing about these Parquet files is that they create row groups and they number them, and then they have like max and min values, etc. So here you can see it gives you the file name, the row group ID, how many rows are in each group, and so forth. Because it has a certain structure, and I don't want to talk about it in detail right now because I have some references to it later in the video. But anyways, you can see here is the structure, or the metadata I should say. There's all kinds of information here. There's compressed size, there's uncompressed size, there's page offsets, and so forth. Max values, min values. So that's a little bit about the metadata you can query. Now, what if I only want a couple of those columns so I can see it a little better? Okay, so here I'm querying for the total compressed size and the uncompressed size. And as you can see here, this is in bytes, and it will tell you per row group how much there is. So one thing I would like to do is see how big is this file. Well, I'm doing a little bit formatting, and I'm doing some casting, rounding up, and then I'm summing up over all these row groups how much is the sizes. So by doing it this way, I can get the output in kilobytes, in megabytes, and in gigabytes. And I'm querying this local Parquet file. So I'm running that, and as you can see, it's not a very large file, as you can see. If you uncompress, it's about half a gig, approximately. So you can see it here. You can run that kind of query over the Parquet file. One thing I can do, too, is I can format the output for my data frames for the Panda, if I set that up like this. So here I'm doing like 2 two decimal points. So as you can see here, I'm getting my 2 decimal because the output here is in a data frame. Now, if I want to change that, I can simply do T, and I can say show, for example, and run it again. And as you can see, now it's outputting it like this. Remember before I said there was an extreme fair value that was $395,000. So why don't we take a closer look at that record and see what's going on in there. So here I'm going to go in and I'm going to query the Parquet file, and then I'm going to do a subquery here that is going to look for the max value in that Parquet file, and it's going to find this 395. And I want to find out the record, so I select everything that has that max amount. So let me run that. And as you can see, here is the output. And if you look at it a little closer, you can see the pickup was at 345.58, so that's almost 346. And the drop up was like 30 seconds or so later, like a couple of 30 seconds later. One person, the distance ran was 0. And if you look here, you can see the pickup location and the drop-off location are the same. So that's really strange. So, you know, if you look at data like this, most likely there's an error here. So anyways, that was just a little bit how you can query these files, etc. Another thing you can do here is you can use this duckdb.sql and then wrap your queries inside as text format, as like I'm doing here. In this case, this might be useful if you want to have a variable and then you want to, say, use it in Python. So let me run this and see what that one looks like. Notice it came back with this other formatting style because I haven't set it back to a data frame. But as you can see, it did a count over the Parquet file and between this date and this date. Now, another thing that you can do in working with this Duckdb magic and the Python underlying code is to merge the two. You can use this flag here, -O for output, and then give it a name, like var2 in this case. So here I'm doing the same query, and I'm using, it has to be in one line here because I'm using a single percentage sign. And then I print out using Python code. So here you can see now when I run this, it came back and you can see it did the same thing. I'm actually referring to this variable so I can use it in following cells, etc. You can also check out what is available here inside this DQL types. And notice there's the data frame, arrow, PL, describe, show, and relation. Those are the ones that are currently listed here. You can also query, let's say you have a multi-join query and you have a bunch of tables and you want to see the table names. One thing you can do, you can run this, and in this case there's only one because that's this Parquet file. But you can see it gives you an output here of the tables that was used in that query. You can also reuse your connections. So here what I'm doing is I'm simply want to get a connection and then just show you the version of what that is. So when I run that now, you can see the DuckDB version is 0.9.2 and there's some other stuff here. Now this is not really important per se, but I just want to kind of throw it in there. You can also create a table in a database here. So notice up here, I only got my notebook and my Parquet file. So what I want to do is I want to create a table. And one thing you can do in DuckDB, you can say create or replace table if you want to run it. I'm not going to create this table here, but I'm just showing you how you can actually use the connection. So you can see here, you can reuse the connection like this. So when you create a connection up here, you can reuse it like this. But one thing we can do is we can pass parameters as well to the queries. So you can give it a name like this, and then you use this -p, and it's ordinals. In this case, if you just put it in your query, it will be like ordinal here. You can see it here. So the first one will be the start date. The second question mark will be the end date. So I'm setting the parameters equal to -p start date, -p end date, and then I use this -o for creating a variable that's going to hold this stuff. And then I'm printing it like you can see here. So when you run it, you're getting this count here, which was by passing in these. So if I wanted to get a different count, I can just say maybe put that 2 days later instead. And now you can see I'm getting a different count. So all I do is change the parameters. You can also create a new database by giving it a name like this, and it will create it in the folder that is your current. Here I'm creating this, and it creates a connection, and then I close the connection. Which I want to show you some other stuff related to it. So when I run this now, notice up here now, it created this database, taxi 2019-04-_06. I can actually go and basically create a new table and load my files in there. Notice I only have this one Parquet file. So what I can do is, I could have gone and downloaded like I did with others, but just to save some time, I'm just going to click on this one and go back and then click on this 06 file and then go to my folder, which is going to be go to my downloads. And what I'm going to do is I'm going to grab those two files. They look like this. Drag them over and drop them over here. Here now you can see they show up 04, 05, and 06. What I can do, I can actually use a technique to create a table where I actually bring it in from all of them. So let me show you what that looks like. I want to create a connection to that database that I just created up here. And then I want to create or replace a table. I want to call it taxi trips. And it's going to be based on this select query. So select everything from taxi underscore 2019 underscore. And then notice what I'm doing. I'm using a star, meaning a wildcard. So we'll pick up 04, 05, and 06. So let's run that and see how that comes through. So I'm running it. And it's loading from all those three Parquet files, all the data. So there should be quite a bit of data there. Now, I didn't time this, but you can see it down here. Okay, it finished about 16 seconds to create that table. So let's take a look and see how much records are in there now. Notice what I'm doing. I'm setting my connection here for my DQL to be the existing connection from up here, as you can see. So I'm using this -CO. So I'm selecting the count from the actual table now in this Duckdb database. So let's see what that looks like. And notice now there's 21 million records in here now. So it loaded in 16 seconds 21 million records from Parquet files into that table. So that's pretty good. From Duckdb, you can run a query and convert it into a data frame directly too using this con.sql by using this function. So let me show you what I mean. So here is without converting it to a data frame. And if I do it this now, you can see now it is a data frame. So by using this .df, you can convert a DuckDB query result into a Panda data frame if you want to do it that way, instead of using this DQL, because sometimes you might write Python code that is not going to be in a notebook like this. So one more thing here, I'm just going to show you that there's also, you can run like summarize statement here. And as you can see here, it summarized this particular query. It gives you averages, standard deviations, quartile, the first quartile, the middle quartile, and so on. So it has, you can actually run stats over this and get some information, as you can see. The counts, the null percentages, etc. So you can summarize as well. Here, I'm going to describe the new table that I created from the database. And as you can see, I'm using the existing connection again. And here you can see the table format in that table inside the Duck database. Here, I'm simply going to run a quick query over this, the data here. Remember, there's 21 million, almost 22 million records in here. And here you can see some of the max and min, and so it should not change very much, but it looks like 2004 had the highest number anyway. And that's the end of this particular notebook. It's kind of nice these days because you can actually open in another window now. So that's kind of nice. You can actually have, I have two instances of the VSCode. So this is the other window. I got this very similar notebook in here, so I'm not going to dwell on this. You already seen a lot of this stuff. So let me just go to the point where I can show you some additional stuff. In case you want to display all the rows in the data frame, because sometimes it cuts it off, just use this set option, display dot max rows. One query you can run too is this select from duckdb underscore settings. And if you look, this duckdb has basically the metadata for the duckdb database. So notice you have things like memory size. You can see down here. You have all kinds of pivot limits and so forth. So this is the data that comes with the settings of the database, like the default setting. So you can run it like duckdb_settings. Then also you can use this exclude. So I'm looking for the size of the memory. And when I run this, you can see it's 26.8 gigabytes of memory that I set aside for this database. Now, notice I'm selecting all the columns, but I'm excluding this particular column from the output. So that doesn't show up. You can use this exclude keyword as well. Now here I got a little information about the Parquet files. This is the stuff I got back from when I did a Microsoft Copilot in my Edge browser. So I just put it in here. You can study it. And what also, I'm going to make these notebooks available for you so you can dig into them. This guy here, this Data Mozart guy, he had a pretty good explanation of the Parquet format. I highly recommend you watch this YouTube video. It's not very long, but it's very informative as far as understanding the Parquet file format and how it uses compression, how it uses columnar stored in row groups and so forth, and how you're actually querying it. So make sure you check that out. That's very informative and very good. I've seen a few of these videos and some of them are too technical, but this guy is trying to explain it in plain vanilla English, so it should be pretty easy. But you'll have much more appreciation for the Parquet file format when you do this. You can also query this Parquet schema. Now, I don't know how much you get out of it, but you can see here, this is the information you're getting out when you actually query one of those guys. So one thing I want to look at is this thing here. So here is some of the output from that Chicago crime CSV files that is in a Parquet format here. You can see that the primary type is things that was the kind of crime was happening. Theft, battery, criminal damage, and so forth. And then I'm sorting the row counts for these guys, descending. So I'm still going against a Parquet file, as you can see, but I'm formatting this query to get it in descending order. And then what I did was, down here, I added year. So as you can see here, now it has a year column too. So as you can see, here is the row counts and the years and everything. What I wanted to show you was, I made a couple of videos in the past about styling markdown tables. That is quite popular. And also for Jupyter Notebooks, how you can style it. So I just want to show you how you can add a little finesse to this output here. So I can create a data frame by copying this data frame. So where did I get that from? Well, remember the output here? You can set it to a variable. So when I run this particular query now, it creates a df1 data frame. So when I go down here now, I make a copy because I don't want to override it, because then I can only use it once. So I'm calling another data frame df2 is a copy of df1, and then I'm saying year, primary type, and row count. Then I use the pandas style features, and I'm setting a background gradient to this theme, this color theme, on the column, as you can see, the axis. So now you're getting a little more colorful output running that query. So when I run this again then, just so you can see it, this is what it looks like. And then I can do the similar things with a df3. In this case, I'm doing a different kind of formatting here. I'm highlighting the min, and I'm using a light green. Now, one thing you notice here is that picks up these two, which I didn't want to cover. But if you try to separate and create one for the styled one and put it together with the original one, you're getting errors. So that didn't work for me. But here you can see, there's the min in light green, as you can see here, for the row count. And here is the min year, as you can see. So it probably did this alphabetically when it sorted this one to try to find the min. So that's another thing you can do. You can style your data frame up like that. Okay, that's all I had for today. I hope you liked the video, and if you did, give me a like and consider subscribing to my channel if you haven't already done so. So I hope this was informative, and I will see you really soon again. Have a great day or night wherever you happen to be.